All right, so here we go. So again, this whole topic is about counting by weighing. The reason why we need to do that as chemists is because if you think about what you would want to know about a chemical sample, like the key thing that you would want to know is how many things are in that sample, right? How many atoms, how many molecules. But they're too small to count by hand, right? You're never going to be able to go in and like count up the number of carbon atoms in the sample or something like that. So we don't do that as chemists. We count by measuring mass. And again, we're going to try to build out the concept behind this with an example that you can see. So I have these volts here, and I did some measuring to determine their average mass. And I say average because although they're all the same type, if you had an accurate enough scale, I'm sure they vary a little bit in their mass. But if I know the average, that should be all I need to know to count them by weighing, right? Atoms are kind of the same, right? We have different isotopes of a given element. They have slightly different masses because they have different number of protons in their nucleus. And so we use average atomic mass in a similar way, okay? So the way I actually measured out their mass is I counted out 20, put them on an electronic balance, divided by 20 to get their average, okay? And the 4 significant figure value that I came up with, we're going to record. It happens to be 4.227 grams. Okay. I'm going to set that up as an equivalent statement for converting. So I'm going to say 4.227 grams equals 1 volt. That is the mass of 1. So let's say I want to count out volts, but I don't want to count them because I want to do it quicker, right? If I want to count out 25 volts, the way I'm going to do that is a calculation with a conversion factor, just to make sure I'm doing it right. I want to count out 25 volts. I want to use my equivalent statement as the conversion factor. So I want to cancel volts. And what I really want to do is figure out if I want to put these, if I want to count out 25 volts, how many grams would I need to put on an electronic balance? I should have mentioned that. And it's 4.227 grams per volt. All right, so my conversion factor would cancel. I'm going to end up in grams, and I will get that number. So I'm taking 25 times 4.227. I could divide by 1. I don't really need to, but for good measure, I'll put it in there. And I get 105.675 grams should be the mass of 25 volts. Okay. The electronic balance I'm going to use only goes to tenths of a gram. So I'm going to go ahead and round that to 105.7. And again, what did I do? I figured out how much mass I would need to measure out to count out 25 volts. So let's do it. Zero it. Sorry, turn it on first. Make sure it's zeros. Take a weighing dish. And I'm actually going to lift this up just a tiny bit. There we go. So the weighing dish has a mass of about 2.1, 2.2. I'm going to zero it with the weighing dish on there so that I'm not weighing the dish. I'm just weighing the stuff. And again, I'm shooting for 105.7 grams. I want to do it quickly. I'm just going to start piling them in here. Getting close. There There we go, 105.7. I did that quickly. I did not count them up, but I have confidence that there's 25 bolts there because I have confidence in my calculation. So ordinarily, you would not drop your bolts. You would trust your calculation, but I want to just prove that it's not magic. It actually works. So I'm going to pull these out in groups of 5. So there's 5. There's 5 more. They roll away on me. There's 5 more. Kind of takes time, right? I wouldn't want to do this every time. 5 more. Five more. It worked. 5, 10, 15, 20, 25. It took me a while to count them out. I don't want to have to do that every time, especially if you're talking about chemical quantities. There would be no way to count them out in that manner. All right, so I want to see how it works in the opposite direction. What if I knew the mass in grams? How would I go about calculating the quantity? So go back to 0. Put a weighing dish on here. So what I'm going to do is just randomly grab some. In fact, I'm going to have one of you do it. Just put some of the bolts in the bin. We'll measure their mass and do the calculation. All right? All right. Just perhaps an amount that's not easy to count. But good? Or you want more? You're good? Yep. Okay, it was this one. Side. All right, so again, you might not see it, but the scale is zeroed. It's reading a negative mass right now because I zeroed it with the dish on there. So it is already accounting for that. I think that's too close to our previous measurement. I think we need more. Just that's good. I want to. Yep. I can edit that out later. Okay. 143 points. We'll call it 8. Okay. So that's my sample mass that I'm going to put here. And I want to count it, but I don't really want to count it, right? So I'm going to do a conversion again. I'm going to take my mass. I'm going to set up a conversion factor. I want to cancel grams. And this time I want to end up in bolts. And again, the equivalent statement was that 1 bolt is the same as 4.227 grams. Grams would cancel. And I think that makes sense, right? I'm going to take the total, divide by the mass of 1 to figure out how many I have. All right, so 143.8 times 1 is just 143.8 divided by 4.227 equals 34.01 repeating, right? I'm almost right at 34. I can't have partial bolt, right? So I'm going to predict that there's 34 bolts in the bin. or in the measuring dish. It worked out pretty darn close, right? I was only off a hundredth of a gram. All right, so again, I wouldn't normally do this because the whole point in measuring the mass and counting it that way is to be quick, but I want to verify that it is 34 bolts. This time, I think I will pull them out in groups of 10 just to be a little quicker. One, two, three, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10. Okay, there's 10. One, two, three, 4, 5, 6, 7, 8, 9, 10. Double check. 2, 4, 6, 8, 10. Keep going. Two, 4, 6, 8, 9, 10, and then 4 in the weighing dish, right? So 34. That took a while to count out 34. Think about how long it would take to count out 1,000 or 1,000,000 or 1,000,000,000, right? You just can't do it. So that is how we're going to measure our chemical quantities. That's how we're going to count them. We're not going to count them. We're going to measure their mass and we're going to do a calculation. Okay. All right, so continuing on with this concept, what if we did want to scale it up? What if we wanted to imagine that we ran a warehouse that sold these bolts? Okay. It might be helpful to have a different unit that was kind of scaled up. Okay. So we're going to define a new counting unit for our bolts. And we're going to call this counting unit a box. And I would literally put the bolts in a box. Okay. The way we're going to define a box is by mass. Okay. So I'm going to define a box of bolts as the number of bolts that would be present in 1 kilogram. Which we remember is the same as 1,000 grams, right? So if I wanted to measure out a box of bolts, I would get a big electronic balance. I would start pouring the bolts on the balance until I got to 1,000 grams or a kilogram. That would be a box, okay? Let's calculate how many bolts would be in a box. So again, in my hypothetical example, I've poured out 1,000 grams of bolts. It's going to be a lot. I want to know the count. Okay, so I want to cancel grams again. I want to end up in bolts. And my equivalent statement is that 1 bolt was 4.227 grams. So grams would cancel. I'm going to end up in volts. I'll clear the we'll get that number. So I'm taking 1,000 times 1 is just 1,000 divided by 4.227. And I get a not very nice number, right? It kind of seems random, but it is kind of random, right? Because I didn't devise it based on a nice round count. I devised it on a nice round mass, okay? And it's not even an even number. It would be really nice if we were closer to an even number, but we're not. So it's about 236, I'll say 574 volts. I can't have a partial volt, right? Again, it would have been really nice if it came out to be like 236.9, but I'm going to round it and say In a roundabout way, I'm going to define a box of bolts as containing 237 bolts. Because that's the closest I can get to a whole bolt, right? Now again, not a nice round number because I based it on a nice round mass, right? I didn't base it on a nice round number, so I wouldn't really expect it to be a nice round number. All right, so continuing on. Go to the next page here. I'm going to write my new equivalent statement that I know now about my boxes. One box of bolts, which would be a kilogram of bolts, is 237 bolts. And if I ran my warehouse, what I would do at this point is I would make a bunch of boxes, right? All I need to do to make a box is pour out 1,000 grams of bolts and stick them in a box. Put those up on the shelf. Pour out 1,000 more grams of bolts, put it in a box, put it on a shelf. So that I have my boxes ready to go because I'm going to start selling these in huge quantities and I want a quick way to pull them off the shelf, right? So following our analogy here, what if you had someone who needs 25,000 bolts, okay? The quickest way to measure those out is not to measure their mass or count them. The quickest way to do that would be to pull the correct number of boxes off the shelf, right? Because I've already made them 1 kilogram each. I know that there's 237 bolts in a box. So that's what I'm going to do. I need 25,000 bolts. And I want to use my scaled up counting unit of boxes as my conversion factor. I want to cancel bolts and I want to end up in boxes because I can pull the boxes right off the shelf. They're all ready to go. One box is 237 bolts. Bolts will cancel. I should end up in boxes. Get that number. So 25,000 divided by 237 is roughly 105.5 boxes. Now, I couldn't really have a partial bolt, but I could certainly have a partial box, right? You could open it up, take half of it out. That's a partial box, right? Again, it didn't come out perfectly equal, one box to 237. So really, I'm probably more like a 3 sig fig answer. It's like 106 plus or minus one box. Don't want to worry about that so much. I could potentially have half a box, okay? So what we've done here is devised a way to count things up, especially huge quantities, okay? There's kind of 3 modes of doing this.
Pardon the interruption. Just wanted to let everybody know that the bundt cake orders will be, tomorrow's the last day. They need them in by tomorrow. You can get them for somebody that's not at the school and take them home. They'll be packaged up really pretty. So bring your $6 tomorrow and it'll be the last day. Thank you.
All right, so real quick. I can measure mass in grams, right? I can convert that to quantity in boxes. That's a way that's particularly useful for huge quantities, like 25,000, right? I could do one more conversion because I know how many pieces are in a box. I could take it all the way down to quantity in pieces. But there might be some cases where I don't really need to do that. If I'm satisfied with the count in boxes, I can stay there, okay? And that's actually what we do 9 times out of 10 in chemistry. We have a scaled up unit called a mole that does the same thing that the box unit does for our pieces of hardware, okay? And that is where we'll start tomorrow.